in today's video, we're going to talk about midpoints and segment bisectors. The first one we're going to talk about is a midpoint. So a midpoint of a segment is a point that divides the segment into two congruent segments. So if we look at this segment over here, segment AB, if M is the midpoint of this segment, then we know that segment AM is going to be congruent to segment MB. And in our last video on the segment addition postulate and congruent segments, we learned if these two segments are congruent, then they have the same measure. So if AM is equal to 3, then MB would also be equal to 3. So let's get into some examples where we are using the midpoints. So in the directions, it tells us that for numbers 1 through 4, M is the midpoint of each segment, and we want to solve for each variable or segment length. So in number 1, it's asking us to solve for X. All right, this one's a little straightforward. So we can set, if we know that M is the midpoint, we know that AM is congruent to MB. So we can set those two measures equal. So X plus 5 equals 10. And X is going to equal 5. Okay, same idea for number 2. So we have M is our midpoint, so QM is going to be congruent to MR, so 7X equals 8X minus 6, and we're going to have negative X equals negative 6, or X equals 6. Okay. And again, we're just kind of following the same idea here for our next couple examples. So for number 3, we want to solve for segment RS. So RS is going to be this whole segment here. Again, if M is the midpoint, I know that RM is congruent to MS. So I can set 6X minus 10 equal to 10X minus 50. And I'm going to subtract 6X from both sides to get 4X, add 50 to both sides to get 40, and X equals 10. Now, the question's not asking me to solve for X, it's asking me to solve for RS. Okay, so what I can do here is I can find the length of RM. All right, so if I take that X equals 10 and I substitute that in for both of these X's, here I'm going to get 6 times 10 minus 10. All right, RM would be 50. 10 times 10 minus 50. All right, this would also be 50. So I know I'm on the right track because if M is the midpoint, these two segments should have the same measure, which they do. And 50 plus 50 is going to equal 100. So RS is 100 units long. And same idea for number 4, we want to solve for CM. So CM is just one of our pieces, but I know that CM is congruent to MD. So I set those pieces equal to each other. And I'm going to get 3X on the right side. I'm going to have 60 on the left. So X equals 20. And 20 plus 16 is going to equal 36. So CM is 36. Okay. All right, now for the next ones, we don't have a diagram. So it tells us that M is the midpoint of segment XY. We want to use the given information to find XM, MY, and XY. And anytime it doesn't give us a diagram, we want to draw a diagram to help us out, okay? So I'm going to draw my diagram first and then fill in the missing pieces. And there is actually a typo here. This is supposed to say 6X minus 2. So we're just going to change that really quick. Okay, so I'm going to draw my segment. This is segment XY, and M is the midpoint. I know that XM is 6X minus 2, and MY is 3X plus 7, okay? So this is just like the ones that we did above, except we had to draw that diagram out first. So I can set my 6X minus 2 equal to 3x plus 7. Subtract 3x from both sides, add 2 to both sides, and we get x equals 3. Okay, and again, now we want to take that x equals 3 and we want to substitute that into xm. So xm is going to be 6 times 3 minus 2. All right, we get 16 over there, so xm is 16. All right, and again, this next step here is a good way to check your answer. So even though I should know that my should be 16, because these two segments should be congruent, we did set them equal to each other, it's just a good way to check your work. So take that extra 30 seconds to substitute that in again, just to make sure you're on the right track. All right, so I get 16 again. I know the fact that I got these two segments to be the same is a good sign that I didn't make a mistake. And then if I have 16 over here and 16 over here, I'm using that segment addition postulate, and that tells me that segment XY is going to be 32. Okay. Let's look at number 6. Again, I want to set up that diagram first. So I know xm equals 5x minus 3, xy equals 8x plus 24. Without the diagram, it's really not that helpful. So I'm going to draw that segment xy with m as the midpoint. So I have 5x minus 3. And then here, instead of giving me my, it tells me that that whole segment xy is 8x plus 24. Okay, so if m is the midpoint, then I know xm is going to be congruent to my. So I know that my is going to be 5x minus 3. And I can set up my segment addition postulate. So I have 5x minus 3 plus 5x minus 3 equals 8x plus 24. So 10x minus 6 equals 8x plus 24. And I'm just going to solve from here to get x equals 15. Okay. Again, I do want to plug these into each of these just to make sure I'm on the right track. So for xm, I have 5 times 15 minus 3, which is going to equal 72. All right, so I have 72. My, all I know is that's also 5x minus 3, so I don't really have to plug that in again. But I'm going to plug 15 back in over here. So 8 times 15 plus 24, that's going to be 144. All right, which I know I should get because 72 plus 72 is 144. So it looks like I'm on the right track. Okay. All right. Okay, now number 7 on the back. All right, this is another one where I'm not given a diagram, so I know I'm probably going to have to draw one. So number 7 says find the value of x if B is the midpoint of AC and C is the midpoint of segment AD, and AB equals 11 and CD equals 9x plus 4. All right, so there's a lot going on here. I definitely want to draw. First, I'm going to draw that B is the midpoint of AC. Okay, so here's my segment AC. All right, B is the midpoint, and I'm just going to mark off that these are congruent segments. All right, so I remember that moving forward. And then it tells me that C is the midpoint of segment AD. So I already have my endpoint A, I already have C, but if C is the midpoint, then I know that I must have this segment D here, okay, where I'm going to draw my 2 tick marks here in a different color. This segment AC is going to be congruent to this segment CG. All right, so kind of a lot going on here. I know that AB is 11, which means BC also has to be 11 because they're congruent. And CD is 9x plus 4. Okay. So how I can kind of start this. All right, I know here I have, oops, that go away. This CD here is my 9x plus 4, which is congruent to that whole piece here, all right, AC. So AC is going to be 11 plus 11. All right, so this whole segment is 22. So I'm going to set my 9x plus 4 equal to 22. And when I solve that, I get x equals 2. Okay, so this one had a little bit more going on in that diagram. You want to be careful as you're reading it that you're making sure you kind of notate everything and use all the information that they give you. Okay, now next thing that we're going to talk about is a segment bisector. So a segment bisector is similar to a midpoint, where a midpoint is a segment bisector. Okay, so a midpoint is a point, and we said that it divides that segment into two congruent parts. Okay, so a midpoint is a point that does that, but you could have a line or a ray or another line segment that bisects your segment. All right, so same idea. A segment bisector is a point, a line, it could be a ray, or a line segment that intersects a segment at its midpoint. So if I look at this diagram here, okay, line K, all right, is a segment bisector. Okay, so it's going to bisect segment AB at points M. Okay, so if it bisects that segment, I know that M is going to be my midpoint, and I know that AM is congruent to MB. Okay. All right, so it's very similar to the idea of a midpoint. A midpoint is what we call that line where the line, ray, line segment, or point bisects it. Okay, so let's look at number 8 through 11. So for 8 through 11, we want to identify the segment bisector and then solve for x. All right, so in each of these, it tells us we have this segment bisector. And we can see that even though it tells us it's a segment bisector, we know that because it does tell us we have those congruent segments there. All right, so here my segment bisector, it's not just that point. All right, that point's actually not named for us. All right, the segment bisector would be that line P. So line P, remember we can name lines using 2 points on that, or that cursive letter at the end of the line. So line P is our segment bisector here, and if I wanted to solve for x, all right, again, I'm just going to set these segments equal to each other, all right, or those segment lengths equal to each other. So 5x plus 3 equals 7x minus 9. We're going to get 2x equals 12. So x equals 6 here. And here we just have to solve for x. We're not substituting anything in. Okay. For number 9, all right, here, if we look at this segment bisector is a ray. All right, so this is some good practice in reviewing how to name line segments, lines, and rays. So in order to name this, we have to start with that endpoint, all right, and then go on and name the point where it's going to go forever in that direction. So my endpoint is R, and this ray goes and extends forever in that direction of point S. Okay, so ray RS is our segment bisector. If I wanted to solve for x here, all right, if I know XR is 7x plus 3, then RY is also 7x plus 3. Okay, so when I use my segment addition postulate, all right, I can take 7x plus 3 plus 7x plus 3 and set that equal to 16x minus 4. Okay, and solve from there. So I'm going to have x equals 5. Okay. Now if we look at number 10, number 10 is similar, all right, where we're given that piece and we're given the whole. All right, but first, let's talk about the segment bisector. The segment bisector here is just a point, okay? It's just going to be that point M. All right, I don't like the way that looks. And another way that we could do this, if we wanted to solve for x here, so I know that if LM is 4x minus 6, then I know that MN is 4x minus 6. If I didn't want to write that out twice, I could just do 2 times 4x minus 6 equals 6x plus 8, and it's really the same thing. Same kind of number of steps, but in case anyone wanted to do that little shortcut. All right. Oops, so this is 12. Okay. So I have 2x equals 20 and x equals 10. All right, and then in our last one, our segment bisector here also is a segment. Okay, so we can say that segment EF is bisecting segment AB. All right, now I don't know that these two are congruent. Okay, it doesn't tell me that information. All right, but I do know that this segment here is congruent to this segment here, so we're going to set those equal. So 3x plus 50 equals 8x plus 30. All right, so we are going to have 20 equals 5x. Divide both sides by 5 and x equals 4. Okay. And in our last problem, we are just practicing sketching. So we're sketching a diagram of the following. So we want to draw a geometric diagram here. Segment JK is bisected by line GH at point P. So I'm going to start by just drawing my segment JK. You know, let's actually use the straight line features here so that it looks a little bit nicer. Okay, so here is segment JK, and it's bisected by this line GH. Okay, so obviously this isn't going to be perfect, but if I wanted to say, let's move that a little bit closer down here. All right, if we said this is kind of the midpoint, this is the point where the segment would be bisected. Okay, so I'm going to draw this line. This is going to be line GH. All right, so I need to put a point G and I need to put a point H on that line, and it is going to bisect that segment at point P. Okay, and if I want to make sure that I know that this is a segment bisector, I'm going to put in those congruent marks there. All right, so I'm going to go back and make sure I have everything that I need. I have segment JK. It is bisected by line GH at point P. So it looks like I kind of have everything notated in this drawing accurately. Okay. If you have any questions on anything from this video on midpoints or segment bisectors, you can comment on the video below. Thank you so much for watching.